binary numbering system, but we won't have time for all of that here. The discipline itself emerged as a person called Charles Babbage, who invented a powerful mechanical calculator, began envisioning a computer that could run programs stored as punched cards. His assistant, Ada Lovelace, created what was the first computer program that could compute Bernoulli's number in 1843. And with fast forward around 100 years, Alan Turing and Alonzo Church formalized the concept of algorithms, which led to the Church-Turing hypothesis, stating that any calculation is possible through an algorithm given enough storage space and time. In the same year, Alan Turing came up with something called a Turing machine. It's a conceptual computer that embodied the principle of modern-day computers, including the idea of a stored program. In 1946, John von Neumann described an innovative model computer architecture that was later known as the von Neumann architecture. It's like a rudimentary CPU, as it has an ALU, or the arithmetic logic unit, an IPU, or the instruction processing unit, and a shared memory space for both the program and the data. In 1959, the first integrated circuit chip was created. An integrated circuit, or IC, is a regular circuit, but you shrink it down many times so that it fits on a very small area. This is what eventually enabled us to have computers the size of laptops and phones. In 1969, computers in UCLA and Stanford connected for the first time, which resembles the internet we have nowadays. And 20 years later, Tim Berners-Lee, a scientist working at CERN, invented the concept of World Wide Web, which was originally envisioned to help scientists share information using automation. You probably see how important this was going to be. So that's it for our computer science history.
Hey, so what is computer science? Computer science, simply put, is the study of computers and computing, as well as their theoretical and practical applications. People with computer science majors are employed in a wide areas of places, and it's considered one of the fastest growing fields. Here are a few examples of the application of computer science. When talking about programming, video game designing, and programming apps for consumer often pop into mind. While this is the most well-known, it is not the only application of computer science. Next of all is a relatively new frontier, AI. AI, short for artificial intelligence, are machines or computers that mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. They can be trained to learn to accomplish tasks, and is quite possibly the future of the technological world. This goes hand in hand with robots, which are machines that are able to replicate certain human movements and functions automatically. Some might even resemble humans. More on the back end of things, there are data structures, used to store data in an organized and efficient manner, and also allows the manipulation of data. Not only is computer science used in the technological field, they are also widely implemented by other fields, such as science to make observations, engineering to plan and design, math to calculate and test models, and many more.
Okay, so I'm going to be covering common myths and misconceptions about computer science that you may or may not have heard. First one is you have to be good at math. Computer science does require math, but you don't have to be a math genius to be successful in the field. The math you learn in the computer science program has a specific purpose, to support the design and analysis of algorithms. Studying computer science teaches you how to solve computational problems. Those problems are then encoded in algorithms, or a list of steps, which is one of the fundamental building blocks of computer science. When designing an algorithm, the computational problem being solved determines the level of mathematics that is needed to be used. Designing algorithms for many computational problems requires no more than high school algebra. Other problems, such as those in machine learning or computer graphics and image processing, require knowledge of probability and stats, linear algebra, and calculus. So if you're proficient in high school algebra or elementary algebra, algebra 1, then you can succeed in computer science. You can learn the required higher level mathematics if needed. Second myth is it is programming. That is simply not true. Programming is an applied activity that you may encounter during study in the that you may encounter while studying computer science. This miscommunication is quite common, and I think based off of research, it's partially the fault of those who are trying to popularize the field that are not computer scientists, or universities attempting to to sell courses in departments by spinning the program to be about vocational skills. The third one is, if you know 1 through 3 plus programming languages, you will not have problems studying computer science. Like I mentioned before, computer science is not all about programming. It will be an asset to know the different languages because you can use more, but that's not really the point. This is true because you may know how to write programs with them, but you don't understand how or why when it comes to how these things work. You may find yourself ahead of the game in introductory courses, which tend to operate like programming courses. But once you get into the actual comp sci content, you will find that it is not at all helpful. Okay, and the last myth is being in a computer-related field means sitting alone at a computer all day. The reality is within computer and information system fields, there are few completely solitary positions. The majority of these roles are on small to medium-sized teams where regular collaboration is critical. The core of computer science is problem solving, and you can't solve every problem alone. More often than not, you'll be interacting with colleagues, clients, and customers on a daily basis.
So I'll be talking about careers. So the first one we have is a software engineer. This is also known as a software developer. Their names are basically synonymous. So software engineers can create, maintain, and improve various software applications. They normally work with a client who needs a functional application, and they're also responsible for planning the hardware and software environments. So as you can see from the picture, there's very little actual coding, especially with the senior engineer. A software engineer mainly focuses on the planning and designing aspects, and they can also do a lot of different tasks and can work from tech companies to corporate offices. So a computer programmer, they're a bit different. So they write code to bring the software ideas into life. So for example, a software engineer would have an idea for a project/app, and a computer programmer would use their knowledge of programming languages and libraries to create the actual source code. A computer programmer also tests and improves already made programs. So now we're going to take a look at this long picture. It kind of shows some key differences between a software engineer and a programmer. So normally a programmer writes an entire program, while a software engineer develops software that's normally used in a system. Programmers normally work individually, and software engineering is a group activity. There's some more stuff here, but these are kind of unimportant, so I'll just skim past them. So a programmer is also aware of the way to code, and they have the skills required, while the engineer follows a scientific method and develop answers to fulfill their needs. We've already covered this, and towards the end, a computer programmer takes a broader approach towards the study of principles, while the software engineering team focuses on the appliance and the maintenance of software functions. And lastly, a computer programmer focuses on the code, and the software engineer focuses on the wider picture. So that's the main difference between the two careers. And if you guys want to look at the picture later or something, you guys can just check out the slides after our meeting is over. The next career is web development. So there are 3 different types of web developers. There is normally a front end, a back end, and full stack. So front end is more focused on the website and the UI, making the visuals look appealing and the web page is more functional. Front end is more about the appearance or the front of a web page, which is what you can see. Backend is the opposite of front end. It deals with the more behind the scenes aspect, with the maintaining of the web server and ensuring the front end is smooth. It also focuses on the application and database. Lastly, a full stack developer is a combination of both front end and back end. They deal with back end work, but are also skilled with the ability to manipulate the front end and change how the site looks. Basically, full stack is just front end and back end combined. Lastly, we'll skim over some of the other different careers that are less important to our lesson today. So database administrators, they manage databases for a company or organization. They deal with the data in a computer system and compile a lot of information that needs to be easily accessed. A systems analyst works with IT and organizes computer systems. They recommend tweaks and updates that will improve the system. Network architects sketch, devise, and design networks that connect various computer systems. They also maintain connections through IP network hardware. Being a network architect requires some skill in network administration. And lastly, hardware engineers, they deal with the more physical and mechanical parts on a computer, for example, your processor or motherboard, and it's much more hands-on than the other careers.
All right, so I'll be discussing a bit about programming and programming languages. So basically, hopefully you guys know, programming is basically just having a human, right, give instructions to a computer. And even in today's world, that processing power is insane, like what Zenkai was talking about, and compared to 50 years ago. And so this is kind of a breakdown. So if you guys see on the screen right now, this is a breakdown of so programming, of course, when you write programs, there should be a way you write the program so that it can understand, and that's called syntax. And it's kind of like kind of comparable to how in English you have grammar. And so there's two main types of programming languages, high level and low level. And it's actually a bit more intuitive to start with low level languages. And basically what low level language is when you create a computer, right, you have the hardware. And there's kind of this usually when you start off, you kind of maybe have, or when I started off, I kind of had this mental block of where's software, where's hardware, and when does that combine? And so low level languages, if you look in the chart below, like machine code and assembly near the red, those basically speak directly, or they communicate directly. The code you put in there communicates directly to the computer and gives it instructions. And from the chart, it directly manages memory. It also has very little abstraction. I'll talk a bit about that later. And it's a lot faster because you're going straight to the computer and you don't have any in-betweens. You don't have any things that are like taking your code and making sure the computer can understand it and things like that. And it also directly corresponds to clock cycles. That's a bit complicated. I think you can just think of it as every time the computer kind of runs a line, it corresponds to the system's internal clock. And since you're communicating right like directly to the computer, it's super fast, but there's its downsides as well, as it doesn't have as much support as high level languages and is harder to learn. Okay, so now talking about high level languages, they're kind of built off these low level languages. And so it's kind of like a machine code and assembly, and then you have like something like C or C++, and then it kind of builds off. So you guys might be familiar with like Java or Python or some other things down here like Perl or JavaScript. And those are built off low level languages, and they kind of use things called interpreters or compilers. Well, I think we'll get more into those details in futures lessons, but basically they have programs and software to help compile down or interpret down and make sure and take your code, which is usually easier to read than assembly or machine code, and it makes it so that the computer can understand it. But there's downsides as well. So these actually have poor performance because you're compiling and you're doing all this stuff to get the computer to be able to understand. But the big contrast between high level and low level is high level you can understand it easily, but the computer really can't. Low level, the computer can understand it really well, but then you really can't. And so those are some examples. Other examples, I think, if we go into the next slide. There is. Okay, so yeah, there's kind of a lot here, but if you look at the very left, right, that black screen, that's just some assembly and some machine code. And so on the very, very left, right, or not the very left, but like the middle column, I guess, you see like a bunch of numbers and letters, and they're like two digits combined, and that's actually the machine code. And the machine code, usually you hear about how computers are just like ones and zeros, right? And so that's binary, by the way. So it's just where you have only ones and zeros. And so I think Zenka actually talked about those punch cards. You'd punch a hole, and that would mean it's a 1, and then you don't punch a hole, and that would be a 0. And so somewhere here, you actually see letters, and it's actually hexadecimal. So it's how to explain this? It's like binary. So binary, you have 2 states, right? So you can have on or off. And then usually when we deal with math class, you have decimal, where the decimal numbering system, where it's 1 to 9 or 0 to 9. And then you have hexadecimal, which happens a lot in computer programming, where it's 2 to the 4 states or 16 states. And so then they have to use 0 to 9, and then they also have to use some letters like A, B, C, D, E, F. And so that's the assembly over there. Or that's the machine code. And then to the right, that's the assembly. And I think we'll be able to get more in depth later, but we don't have that much time today. And then you also have some logos of just some programming languages like C++. The one next to it is Python. And you also have JavaScript and Java. And even though JavaScript and Java might sound pretty similar, they actually have pretty big distinctions. JavaScript is usually used for like making websites and browsers and things like that, or not making browsers, but making websites on browsers. And then Java is for more like just like general software programming, even for like things like Minecraft. But on the left, you can see next to the Java logo is how it takes your Java file, right, that you code, and then it actually compiles it with their Java C compiler, and it makes it so that it turns into a .class file where it's bytecode, so that depending on what computer you're on, Windows, Linux, or Mac, the computer can actually understand what you're giving it, and then it uses Java Virtual Machine to run it. And I think that's about it. Or okay, a quick side note: the assembly that's on the black screen to the right is actually x86, and that's basically, you might know about the company Intel. Your computer might be even running Intel chip, and that's the assembly syntax used to write in their chips. So yeah, I think that's about it.
All right, so that's basically all we have for like our sections, and now we're gonna like have a Jeopardy game. So this is gonna be a bit complicated because there's no simple way to do this, and it's also the first time we're doing this, so hopefully this will run smoothly. But the game plan is gonna be we're gonna have 4 teams, and each team will have 1 officer as like your team leader. So I'm gonna put everyone in a breakout room, and you'll either be in breakout room 1, 2, 3, or 4. And because I can't share the Jeopardy game, I can't share the screen while you guys are in breakout rooms, you guys are going to have to go on Discord and join the correct voice call as the team you're in. So basically, the first step is going to be joining your breakout room, and I'll automatically assign that. And then when you're in the breakout room, come up with a team name with the rest of your teammates. And after that, try and join the correct voice call. So if you open up Discord and navigate to our server, which you're hopefully in, you'll notice that you should be able to see 4 categories, 4 different teams, which is team 1, 2, 3, and 4. Whichever breakout room you're in is which like category, which voice call you should be joining. So if you're in team 1, make sure you click on the team 1 little voice icon and join that call. And then you can leave the breakout room and join back to the main room. So does anyone have any questions regarding the breakout rooms? Or does anyone have any questions regarding the lessons and the sections that we just covered? You can unmute or use the chat. It doesn't matter.
Wait, are you going to talk about how do you want to talk about how each person, like each person of cabinet is going to be from a certain team? So like I'll be in team 4, and then like, and then like.
So basically what Daniel is saying is that each team will have 1 like representative, which is going to be your officer. So if you're in team 1, you're going to be in Zenkai's team. Team 2 should be Josh, and team 3 is Emma, and team 4 is Daniel. So how it's going to work is we're going to have a buzz-in game with the 4 officers. And when I read the Jeopardy question and like share the Jeopardy question, and if you or one of your teammates know the answer, make sure to tell your representative, Zenkai, Josh, Emma, or Daniel, tell your representative that, hey, I know the answer, and they'll try to buzz in as fast as possible. And whichever team buzzes in first will get the first shot to answer the question. So if your team buzzes in first and is about to answer the question, make sure you go and tell your officer what you think the answer will be. And that's how we're going to do it. Also, I think I saw one question in the chat, the software developers like programmers. Oh yeah, Dan, you already answered that. The assigning the teams, it'll just be completely random. So that's it.
So you'll be moved into a Zoom breakout room, and then based on that room number, you'll join the Discord call. Yeah, it's kind of
just make sure if you have any questions, just talk to the people in your breakout room, and it should be fine. With that being said, I'm going to open order rooms, and hopefully you guys are all in the rooms. Okay. Yeah, I think the rooms are all closed. So let me create the buzz-in code. Okay, so I think we can start or pretty much get ready to start. Wait, Daniel and Zenkai and Emma, can you guys join the buzz-in?
Are you able to see me now?
Yeah, I'm missing Zenkai, I think.
I know my computer is really laggy because of Discord and Zoom, and yeah, this is epic.
It's okay.
Okay. Can you see me now?
Yeah. All right. So, team 1 or team unicorns? Zenkai, which category and which number is your team choosing? So make sure every team is ready because we don't got a lot of time left. So we're gonna like kind of speed run through this.
Mid 400.
All right, so I'm gonna click on a question and I'm gonna read it. Then I'm gonna unlock the buzzers for you officers. So there's a lot of this in the field, so you won't always be in the front of your computer. All right, so Team Unicorns, Team 1, they're the only team to buzz. So what do you guys think?
Sure is not.
Hello?
What is true?
Okay. So the answer was actually the collaboration between different people. It's okay. So team 2, which category number do you guys want?
Careers 200.
All right, so knows computer languages, codes programs, and brings software designs to life. Guys, need a buzzing. All right, so coding chips, what do you guys think?
Software developer or what is software developer?
Sadly, it's what is a computer programmer? As you can see, computer programmer, they're the one who codes and brings the software designs to life. But you're pretty close. Team 3.
Intro 300.
So a process of reducing the amount of code needed to perform a certain task and only include relevant information. Team Unicorns.
So someone in our team said, what is compiling?
The answer was abstraction. Unlucky. Team 4.
History 400.
The oldest commercially available programming language is
Lucas says Fortran.
you didn't buzz, sorry. Zenkai, what do you guys think?
Our team said Fortran.
Oh. Congrats. So I guess we can do like a couple more questions. So Zenkai, since your team got it right, you guys can choose again.
History 300.
So the first mass-produced computer. Team Unicorns again.
Our team said, what is IBM 650?
IBM 650 was the correct answer. So seems like Team Unicorns are pretty ahead. I think we'll do one last question. Team Unicorns. What category and point number do you guys want?
Wait, was that to me?
No, but Zenkai, you guys have
History 100.
So measures a computer's ability to think like humans. Oh, Team Unicorns again.
Our team answered, what is a Turing test?
What is a Turing test is correct. So I think that's about it for our game. So Team Unicorns have won, but the bright side is everybody else is second place. You guys have all tied. We hope you guys had some fun and learned a bit. We understand the first couple like meetings have been a bit boring, redundant because we haven't gotten extremely hands-on, but we felt like we needed to give a proper introduction to what this club is and what is computer science. But the bright side is next week we're going to be starting on programming languages. So with that, I think we're pretty much done. Does anyone have, if you guys have any questions, you can email us, message us on Discord or Remind, or we can see you guys next week on Wednesday, same time.